All right, so lesson 14.2 is all about arithmetic and geometric sequences. And as it says, two common sequences that appear frequently in math are the arithmetic and geometric sequences. We're going to start with arithmetic. An arithmetic sequence is one in which the same number is added or subtracted from each term to get the next term in the sequence. The number you add or subtract is called the common difference. Handy rules involving an arithmetic sequence. Your first term is your first term. Your second term is your first term plus your common difference. Your third term is your first term plus 2 times your common difference, and so on. Here is a very, 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 very important formula for you to know. To find any term, it's going to equal your first term plus n minus 1 times your common difference. Okay, so let's take a look. It says, are the following arithmetic sequences? In order to be arithmetic sequences, they must add or subtract by the same number each time. So if you look at the first one, from 3 to 8 is 5, from 8 to 13 is 5, from 13 to 18 is 5. So these are all plus 5, so yes. And we'd say yes with a common difference of 5. Okay, let's look at -2, -12, -22, -32. In this one, they're all going down by 10. So D would equal -10. All right, let's look at our next one. 2, 4, 8, 16, 32. So to get from 2 to 4, I add 2. But if I add 2 to 4, I don't get 8. So this would be no. And for the last one, let's see, we're going up by 0.5. So yes, and D would equal 0.5. All right, so we have the formula for the nth term of an arithmetic sequence up again. We need to remember that a sub n is equal to a sub 1 plus n minus 1 times d, where a sub n is the term you're looking for, a sub 1 is your first term, n is your number of terms, and d is your common difference. So knowing that information, it says, given two terms in an arithmetic sequence, find the common difference, the 52nd term, and the explicit form. All right, so the first thing you want to do is you want to find the common difference. For the common difference, okay, just think slope. What is the difference between these 2 points? Well, the y values are 96 minus 70, and the x values would be 33 minus 20. Okay, so let's think, what is this? 96 minus 70 is 26. 33 minus 20 is 13. So there is a common difference of 2. So what does that help us do? We now know that a sub n is equal to our first term, which we still don't know, plus n minus 1 times our common difference of 2. So at first, it seems like we don't have enough information to solve the rest of this problem, to find the 52nd term or the explicit formula. But what we can do next is we can actually find out the first term by using either of these values. Okay, we know that a sub n, or a sub 20, I should say, equals 70. So we know that 70 will equal our first term plus, what's our number of terms here? 20 minus 1 times 2. At this point, if you stop and you look at your equation, you see that you have everything but your first term, so you can solve for it. So 70 will equal our first term plus, let's see, 20 minus 1 is 19. 19 times 2 is 38, meaning our first term is 32. So now we can say that our explicit formula is a sub n is equal to 32 plus the number of terms minus 1 times 2. So there's our explicit formula right there. Okay? Now we can use that to find the 52nd term. So the 52nd term would be a sub 52 is equal to our first term plus the number of terms, so 52 minus 1 times 2. So let's clean this up. We're going to get 32 plus 51 times 2. Let's see, 51 times 2 is 102. So 32 plus 102 will give us, let me erase that last part. That is messy. Try that again. So we're going to get 32 plus 102, which means our 52nd term is 134. All right, do you remember lesson 14.1 where we had to find the sum of a series and we literally had to sit there and we had to add up every single number? So, quick story. There was this guy, might even be this guy up here. His name was Gauss. Okay, true story. I might have spelled his name wrong, but it doesn't matter. Okay, when he was in kindergarten or first grade, he drove his teacher nuts. Okay, he'd always finish his work, and he was one of those students that really gave the teacher a hard time. So the teacher thought that he would be that he or she would be super creative and keep this guy super busy for the entire class. And he told this kindergartner or first grader he wanted him to add up all the numbers from 1 through 100. Okay? And what he found is that Gauss did this in like a minute and then came back to the teacher and said, hey, I'm done. The answer is blah, blah, blah. So what did Gauss do? Well, Gauss was able to figure out that the sum of the first 100 numbers is the following. Well, look at this. If I add 1 and 100, I get 101. If I add 2 and 99, I get 101. If I add 3 and 98, you guessed it, I get 101. So what he found is that 101 kept showing up over and over and over. Well, how many times did it show up? It showed up 100 divided by 2 times. I purposely said it that way instead of just saying 50 times. He took the number of terms he had, he cut it in half, and then he added the first term and the last term, which gave him the 101. Okay? That's where the sum of an infinite or finite arithmetic sequence formula came from. It came from a kid, kindergarten or first grade, honestly. Okay, if you don't believe me, look it up. So the sum of the first n terms of an arithmetic sequence is given by the sum of the n terms equals n times your first term plus your last over 2. Very important formula. So let's use it. It says find the sum of the first 20 terms of the arithmetic sequence 2 plus 6 plus 10 plus 14 plus 18 and so on. Well, the first thing we need to know is what's a sub 20? Okay, well, a sub 20 is going to equal your first term plus the number of terms you have minus 1 times your common difference, which here is 4. We just learned that in the problem before. So we could say a sub 20 is equal to 2 plus 19 times 4. Let's see, 19 times 4 is what? 76 plus 2 would give us 78. So we found our last term. So now to find the sum of 20, it's s of 20 equals the number of terms we have times your first plus your last over 2. Well, let's see. 2 plus 78 is 80. So we're going to have 20 times 80 over 2. Well, half of 20 is 10. So 10 times 80 would give us 800 as our answer. So that's our answer right there. Then it says, suppose the sum of the series has a sum of 2,178. Find n such that s of n equals 2,178. Suppose the sum of the series has find n such that s of n equals 2,000. We're going to do that in another video because I believe I'm running out of time. Okay, so that will be your next video. All right, let's take a look at part B now. That says, suppose the sum of the series has a sum of 2,178. Find n such that s of n equals 2,178. Well, what do we know? Okay, we know that 2,178 is going to equal n times your first term, which is 2. We know that from part A, plus the last term, which we don't know, over 2. Okay, so it seems like that's all we know right now. Well, let's not forget that the formula a sub n equals our first term plus n minus 1 times d can also be used. Well, we don't know a sub n, but we do know that it's equal to 2 plus the number of terms minus 1 times our common difference of 4. So we can say that a sub n is equal to 2 plus 4n minus 4, which simplifies to 4n minus 2. So we know that a sub n equals 4n minus 2. So we can now put that in our equation. We can say 2,178 equals the number of terms times 2 plus 4n minus 2 all over 2. All right, well, let's think about this. The 2's are going to cancel each other, right? So we're going to get 2,178 equals n times 4n over 2, which we can say 2,178 is equal to what? 2n squared. Okay? 4n times n gave me the 4n squared, and then divide it by 2, which means I can divide by 2 to get n squared equals, I don't know, what is 2,178 cut in half? I should know this much easier. 17 is what? 8, 16, 18. So it'd be 1,089. Therefore, n will equal plus or minus the square root of 1,089. Well, what is the square root of 1,089? I think it's 33, but let me double check. 33 times 33 will give me a 9, a 9, a 0, a 9, a 9, 8, 1,089. So we can say here that n is equal to 33. All right, so the other type of sequence we're going to be learning about is geometric sequences. So a geometric sequence is one in which the same number is multiplied or divided by each term to get the next term in the sequence. The number you multiply or divide by is called the common ratio, usually denoted by r. And the equation we need to know for this one is a sub n is equal to our first term times our common ratio to the n minus 1 power. So it says, determine if the following sequences are arithmetic, geometric, or neither. So always want to start with arithmetic and see if you can eliminate anything. In the first one, I'd have to add 2. 2 plus 2 doesn't give me 6, so I know it's not that. So now let's try multiplication. I could do 1 times 2 is 2, but 2 times 2 does not give me 6 again. Therefore, I know that this is neither. All right. Let's look at the next one. How do I get from 81 to 27? It could be subtraction, which would make it arithmetic, but you can already see the difference between 81 and 27, and then 27 to 9 is way different. So what I do for number 5 is I say, well, what's 27 over 81? And if you break that down, you're going to get 1/3. Well, what's 9 over 27? Again, you get 1/3. What's 3 over 9? Again, you get 1/3. So what we did is we found that our common ratio is r just by doing that. So this is geometric, and the equation for it would be a sub n is equal to our first term times 1/3 to the n minus 1 power. All right, let's look at number 6. In number 6, I can see that this is arithmetic. It's going up by 5. So for this one, I can say my equation is a sub n is equal to my first term plus n minus 1 times my common difference of 5, which when I simplify it will be what? It'll just be 5n. A sub n equals 5n for that one. All right, so again, the nth term of a geometric sequence with first term a sub 1 and common ratio r is given by a sub n is equal to a sub 1 times r to the n minus 1 power. Example 7 says the third term of a geometric sequence equals 64, while the common ratio is 2. So we know n equals 3. I'm sorry, what was I about to say? A sub 3 is equal to 64, and we know r is equal to 2. Write a rule for the nth term. Well, we know that 64 is going to equal our first term, which we don't know, times 2 to the 3 minus 1 power. So 64 is going to equal our first term times 2 squared, which is 4, meaning our first term is going to be whatever 64 divided by 4 is, which I believe is 16. Now that we know that, we can write out the nth term. So we can say a sub n is equal to our first term times our common ratio of 2 to the n minus 1 power. Okay, now we can find the nth term. So for the nth term, or the ninth term, I mean, we're going to say a sub 9 is equal to 16 times 2 to the 9 minus 1 power, which is 16 times 2 to the 8th, which 2 to the 8th, I don't know. I can't do that in my head right now, but you can figure that out. You can do 2 to the 8th, whatever that answer is, and then multiply that by 16. Okay, so just like with arithmetic, there is a formula for geometric to help us find the sum. It says the nth term of a geometric sequence with first term a sub 1 and common ratio r is given by the sum is equal to your first term times 1 minus r to the n over 1 minus r. So example 8 says find the sum of the first 10 terms of the series 1, 5, 25, and so on. Well, we need to know what a sub 10 is in order to figure out how to find the series. Or do we? Now that I think about it, let me take that back. We do not need to know the 10th term. Look at our formula. Okay, it says that s of 10 will equal our first term times 1 minus 5 to the 10th over 1 minus 5. So sorry about that. I was thinking arithmetic for a minute. You don't need to know your last term. So when we simplify this, this will equal, we don't need the 1 in front, so it's just going to become what's in the parentheses. So it's going to be 1 minus 5 to the 10th over negative 4. Okay, so let me get out my calculator. What is 5 to the 10th power? Okay, just like I did in my head. It'll be 1 minus 9, 7, 6, 5. I can't even read these numbers right now. Geez, 625. All over negative 4. So 1 minus 9765625. And it did it wrong. Annoying. So bear with me a second, guys. Let me see if I can get this done. I should have been a prepared teacher who had my calculator up. So it'd be 1 minus 9765625, which equals negative 9765624 divided by negative 4. It's going to give us what? Is going to give us an answer of 2,441,406. So the sum of the first 10 terms of this geometric sequence is the amount of money I wish I made, but I don't. Okay. And then it says, for which term would S of n equal 3,096? So we want to know when 3,906 is equal to our first term times 1 minus 5 to the n over 1 minus 5. So let's think about this. We're going to get 3,906 is equal to 1 minus 5 to the n over negative 4. So how do we solve this? Okay, we're going to multiply both sides by negative 4. What are we going to get? 3,906 times 4. So we're going to get negative 15,624 equals 1 minus 5 to the n. We're going to subtract 1 to get, let me move this up a little bit, to get 15,625 is equal to negative 5 to the n. What would we do from here? Let's see. Let's think about this. Okay, from here, I would divide both sides by negative 1 to get negative 15,625 is equal to 5 to the n. And what you will see is that if you turn this into negative 5 to the 5th, that'll equal 5 to the n. Therefore, n must equal 5. That was a tough problem because of those negatives. If I confused you or if I skipped any steps there, let me know and we'll go over this together in class.